In this video, we will review the diaphragm and cross-frame enhancements in the latest release of OpenBridge Modeler. For concrete diaphragms, the enhancement is that now they can be placed in between beams on adjacent spans. For cross-frames, a new option is introduced to adjust the orientation of connection plates. A new centerline reference option, center of gravity, is now available. It is now possible to use double angles as connectors, and cross-frames can be centered vertically. Starting with the diaphragm enhancement, they can now sit between different beam groups, but since they are always referenced to the beams in OBM, it is not possible to create them independent of the beams. To apply this new feature, the diaphragm needs to be touching beams from at least one group, and as long as this condition is satisfied, any thickness can be assigned to the diaphragm. In OpenBridge Modeler, I will fill the gap on the pier between the beams with concrete diaphragm. I start by measuring the distance between the ends of the beams, and it is 1.5 feet. To place the concrete diaphragm, I will use the Place Diaphragm tool in the Superstructure group of the Home tab. When deciding on the diaphragm thickness, half thickness should be equal to or greater than the distance to the nearest beam. I will leave it as 1 foot for now and adjust the top and bottom vertical and horizontal offsets. For the location of the diaphragm, I will enter the distance to the pier support line. And when I validate this information, I will receive an error since the resulting diaphragm would not be touching either of the beam groups. But if the thickness is increased to 1.5 feet, the error will be removed and I can save the diaphragm with these properties, and it will be inserted in between the beams above the pier cap. Moving on to cross frames, the first enhancement is with the orientation of connection plates. Previously, the connection plates were always leveled in OBM. Now the orientation of the connection plates can be set to along left diagonal or along right diagonal in addition to level. In OpenBridge Modeler, the connection plate orientation can be set through the Connection Plates tab of the Cross Frames library. For X-Frame 1 for steel beams, I will go to the Connection Plates tab. And for the center plate, change the orientation to along left diagonal. So the center connection plate will be aligned relative to the left diagonal. And when I click save, the X frames on the model will be updated with the new orientation of the connection plates. The second enhancement with cross frames is the new centerline reference. In the cross frames library, the previous options for centerline reference were top, middle, and bottom. Now a new option, center of gravity, is introduced here. When sections from the SPC are used, the center of gravity information for cross-frame members can be read from the database and the members can be positioned accordingly. Transfer to analytics is limited currently. The center of gravity option is not available for centerline reference in LeapBridge still. The centerline reference is specified through the Members tab of the cross-frames library for each member. To modify the centerline references of the members of these inverted V-frames, I would go to the Cross-Frames library, select the inverted V-frame template, and in the Members tab for the top strut, change the centerline reference property to center of gravity, and update drawing to see the change being applied in the graphics view. This needs to be done for each member individually, so I can repeat the same for the bottom strut and update the drawing. The third enhancement is specific to concrete beams. Double angle connections can now be modeled in OBM. Under the cross-frame definition, connector angles can be chosen from the library, or L or WT sections can be selected from SPC shapes. The double L option is only applicable to diaphragms and not to other types of cross-frames. For others, it will be grayed out automatically. To add diaphragms in between concrete beams with these new connector options, I will use the Place Cross Frames tool. Here I will start by adding a new row in the table, specifying the left and right locations on the first bay. I will choose Bent Plate Diaphragm as the cross frame. For the template, a connector angle can be chosen from the Connector Angles library, or an L or WT section can be chosen from Rolled Shapes. I will use A2. Then adjust the left height, offset, check level option, and the double L checkbox is in the last column. But this is active if a diaphragm is used. If another type like frame inverted V is used instead, double L option will be grayed out. I will delete the second row and copy the first one to all base using the copy tool here. After clicking save, the diaphragms will be placed between the concrete beams with double angle connectors. The fourth and last enhancement for cross frames is a new option to center cross frames on steel beams vertically. The vertically centered checkbox is added to the cross frame placement dialog to enable this, and the same option is available in the cross frame location wizard dialog. And if this checkbox is checked, the cross frames are placed at the mid-height of the supporting stiffener. To vertically center these diaphragms in OBM, I will open the cross frame placement dialog through properties. The vertically center option is available in the last column here. After flagging it in both rows, I will copy this to all base using the copy button. The same option is also available in the wizard. After clicking save, the change will be applied on the diaphragms on the model, and they will be centered vertically at the mid-height of the stiffeners.